All right, think about the sheer massive scale of the global agricultural industry for a second. It's an absolute marvel, right? This finely tuned machine that literally keeps billions of people fed every single day. But here's the catch. This monumental system relies heavily on our planet's most vulnerable natural resources. So today, in this explainer, we are opening up the industry's ledgers. We're looking at something far more complex than your standard profit and loss statement. We're going to look at the true audited cost of food.
You know, for the longest time, environmental impacts were basically just viewed as ecological problems. But that narrative, it has fundamentally shifted. Take a look at this. For big agriculture, managing sustainability risks is absolutely critical to securing a reliable raw material supply and reducing the risk of price volatility over the long term. Basically, environmental risks are severe financial risks now. If an ag company can't manage its environmental footprint, it faces supply disruptions, massive price swings, and honestly, an absolute inability to secure the basic materials it needs to even survive. Now, to track these massive financial and ecological risks, the industry desperately needs a rigorously standardized rulebook. Well, enter the SASB standards, which are now actually under the stewardship of the International Sustainability Standards Board, or ISSB. This isn't just a set of vague suggestions, and it's definitely not corporate greenwashing. It is a strict, documentary-style framework for measuring environmental and social impact. It literally forces agricultural companies to account for their sustainability performance with the exact same precision and legal liability that they use to track their financials.
So we are not dealing in abstract concepts or PR speak here. We're dealing with hard, cold, quantitative metrics. As you can see, we're tracking metric tons of carbon dioxide equivalent, gigajoules of energy, and thousands of cubic meters of water. This right here is the structural foundation we'll be using today as we investigate the 3 critical pillars of environmental disclosure required for agricultural products.
Okay, let's dive right into Pillar 1, greenhouse gases, the invisible footprint.
This represents the monumental challenge of tracking the invisible footprint left behind by massive processing plants, global freight fleets, you name it. To understand greenhouse gas reporting, we really have to start with Scope 1 emissions. This is the absolute baseline for all corporate climate accountability. Notice the very specific phrasing here, before accounting for offsets, credits, or other compensation mechanisms. So companies can't just, buy a forest somewhere else and claim their processing plant emissions are zero. No way. They have to report the gross direct gases emitted right out of their own smokestacks and exhaust pipes, strictly following the greenhouse gas protocol.
And what's really fascinating about this environmental audit is the sheer technical depth of the whole thing. It's not just about carbon dioxide. The standards require companies to consolidate and track their emissions across all 7 of the highly specific gases regulated under the Kyoto Protocol. We're talking everything from methane generated in agricultural processes to hydrofluorocarbons used in massive industrial refrigeration systems. Every single one of these gases has a totally different heat-trapping capability, and these ag companies are legally and financially bound to track all of them.
But here's the thing. Simply putting a number on a spreadsheet, that just doesn't cut it anymore. As the reporting standards mandate, agricultural entities must explicitly disclose their actual, actionable strategies to manage and reduce these emissions. Investors are asking, are their targets absolute, or are they intensity-based? What are the timelines? Are they actually investing in fleet fuel efficiency or alternative fuels? They want to see exactly how these companies plan to navigate future climate regulations like cap-and-trade systems.
Moving right along to Pillar 2, energy management, the power drain.
This brings us to the intense, raw power drain required to mill, process, and manufacture global agricultural commodities day in and day out. Under the rules, companies have to meticulously report their energy consumption in gigajoules. But actually, more importantly, they must contrast the percentage of their energy pulled from the traditional electrical grid against the percentage sourced from renewable energy. We're talking wind, solar, hydro, and third-party certified sustainable biomass. This comparison is absolutely vital because it shows whether a company is actively insulating itself from fossil fuel volatility or if it remains dangerously dependent on the old grid.
So why is that transition so important? Well, because if an agricultural processing company has poor energy management, they are staring down the barrel of some severe financial trade-offs. They become entirely exposed to volatile fuel prices and supply disruptions. As climate regulations tighten up globally, their operating costs will inherently skyrocket compared to a competitor who actually had the foresight to invest in efficiency and renewables. It's a direct hit to their bottom line.
Before we move to our final pillar, I want you to consider a specific number for a second: 100. When calculating the impact of their emissions and energy use, companies must use the 100-year time horizon global warming potential values established by the IPCC. This number perfectly encapsulates the long-term thinking required in modern sustainability accounting. You aren't just reporting on the impact your company is having this quarter, or even this decade. You are literally financially accounting for the impact your operations will have on the planet for the next century.
All right, that brings us to Pillar 3, water management, navigating resource scarcity.
This is where we hit the critical intersection between incredibly thirsty agricultural processes and the growing crisis of global water scarcity. To put that thirst in perspective, it can take roughly a gallon of water just to produce a single almond, and nearly 2,000 gallons to produce a single pound of beef.
Wow.
Under the standard, companies must use specialized tools, like the World Resources Institute's Aqueduct tool, to identify facilities operating in regions with extremely high baseline water stress. That means greater than 80% of the available water in that region is already being competed for. If a processing plant is located in one of these zones, their water supply isn't just an operational requirement, it is a massive, ticking risk factor.
Now, there is a crucial and honestly often misunderstood difference in water accounting: withdrawn versus consumed. Withdrawn simply means taking water from a local source, like a river or municipal supply. But consumed means that water is permanently gone from that local catchment area. Maybe it evaporated during the cooling process, or maybe it was directly incorporated right into the agricultural product itself. Understanding this distinction tells us exactly how much of a permanent drain a facility is placing on the local water table.
And if companies don't manage this resource responsibly, or say they violate their discharge permits, the consequences escalate super rapidly. The standards force companies to disclose any formal enforcement actions taken against them for water quality violations. And let me tell you, this isn't just a slap on the wrist. It starts with administrative penalty orders, moves up to strict compliance orders, and can culminate in full-blown judicial actions. Mishandling wastewater in this industry leads straight to the courtroom.
So, let's look at the bottom line. From compliance to survival.
Let's zoom back out for a second and wrap this whole thing up. We've looked at the greenhouse gases, the energy drain, and the water scarcity. Combined, these three pillars represent far, far more than just a basic compliance exercise. They are the ultimate test of an agricultural company's survival in the 21st century. This dense accounting standard translates directly to massive real-world operational changes. To mitigate these risks, these companies have to completely rethink their business models. I mean, they must meticulously assess facility locations based on water availability, aggressively improve their daily operational efficiency, pour major capital into alternative energy sources, and actively engage with local regulators and communities. The numbers on the spreadsheet are literally driving the physical transformation of the industry.
I really want to leave you with this thought to ponder. We've seen how incredibly rigorous these reporting standards have become. So if every drop of consumed water, every gigajoule of grid energy, and every metric ton of Scope 1 carbon is now thoroughly audited and placed directly onto the corporate balance sheet, how will that inevitably change the true long-term cost of the food sitting on your table right now? Thanks for joining me for this explainer. Keep asking the big questions about what's really on your plate.